Hi everybody, I just want to share with everybody my enclosure. I've seen lots of enclosures and very complicated, so what I did is I created a frame around the printer and I still need to enclose the filament roll so that it can get some heat. I've put a door here in the front, so if you want to print ABS, you're going to use the enclosure. If you're just going to print PLA, you can actually detach, everything. I put Velcro, and you can just take you can take this whole side, which seals the machine perfectly, and you've got an open machine to use it with PLA or anything that doesn't need the enclosure. So yeah, I think it looks okay. It works pretty well. It keeps the heat inside very nicely. So just an idea, instead of going to spend so much money. And this is just windscreen shields that I've put some Velcro into it and sealed it all the way around, and it keeps the heat in very well. So just an idea, and please guys, let me know what you think. Cheers. Hi everyone, I've built a 3D printer enclosure, which a lot of people needs it when you want to print ABS, not PLA, but with ABS you really battle to print if you don't have an enclosure. And I've posted it on Facebook, and some of the guys really liked it, so I'm gonna try and show you step by step what I did. I'm not gonna show you how I made it because it's already made, but I will show you the products that I used, and it's really very easy to build and very cost efficient because you don't have to spend a lot of money. So let me start. Okay, so welcome to my garage where I do all my small projects. And what I did is I took a 16 millimeter thick piece of plywood, and I placed it on my CNC, which, by the way, I built it myself, but nevertheless, and I've cut it a 650 wide by 750 long piece of board. If you don't have a CNC machine, obviously most people don't, you can use a router, and then you can just cut a recess that will be 20 millimeters wide by 8 millimeters deep. So remember, 20 millimeters wide by 8 millimeters deep recess where your brackets are going to fit. Okay, so I 3D printed these corner brackets, okay, which I will place a link on the video below. And as you see here, these corner brackets are what creates the frame. They get fitted on that recess that I mentioned earlier on, like that. They get bolted from underneath. And then this is a fiberglass rod. You can also use a wooden rod. It's 13 millimeters diameter. I use the fiberglass because it is far more stable than the wood. And basically what you want to do, you want to create a frame like this that goes around your wooden frame. Then you want to cut a piece of perspex, same dimensions as the board, and you want to place this bracket, another bracket, so you're going to need 8 brackets, 4 for the bottom and 4 for the top. And you want to place these brackets, glue them, and then screw them in with some screws on top of the perspex. And again, what's going to happen is this without that. So you're going to have a frame like that with the rods going around, and that will be the top of your machine. Here you can see how I screwed and glued the corner brackets, as I mentioned. So there are 4 of them. There is the rod again going all the way, and then I've printed these brackets that fits inside there, and there you fit your Velcro. I will also put a link for these corner brackets. It is easier than to put, but you can also just fit the Velcro in here and go over your perspex. Okay, so to make it look nice, I took the rod and I got this not so fancy paper. You place the rod there and you can just roll it around, and that will cover the rod and gives it a nice finishing. So you don't have to have this fiberglass rod or wooden rod, and it looks really very nice. And as you can see now, let me try and show you this rod now. There is the fiberglass, and now it's got a carbon fiber look, which looks very nice. It's just finishing touches. Note that I did exactly the same thing on the board, so that goes with the brackets that are black. So I've covered the board also with this paper. This paper is very, very cheap. It's just to give it a nice finishing and a nice look, to your machine. As you can see, there is the paper. It's self-stick paper, so it is glue on one side, so you must just have to trim the corners. Doesn't have to be very fancy because the brackets actually sits on top of it, and you can also see there that seal, that rubber that I've placed to seal from the inside out with the rod sitting on top of it, so that the heat stays inside the machine. Okay, so you see what I've done is with a Stanley knife I cut 20 millimeters off the paper, okay, and then that will fit perfectly on a bracket. You see the bracket has got a hole there. You just drill it with a 3 millimeter. Once you've got the brackets placed on a corner of your hood, okay, and once your bracket is fitted onto your hood, you just drill a hole there and you put a screw, and then this rod cannot turn. Note that the one corner on the hood has to be loose, because that is going to be your turning point for your door, for your front door. So you can screw all the corners, but the left hand side corner or the right hand side corner, whichever side you want to open your door, that has to be loose. You are going to later on put your perspex on that same rod with a couple of screws, and that becomes your hinge point to open and close your door. As mentioned earlier on, here I've made 2 pieces of perspex, okay, 2 strips, they're 40 millimeters wide, and then you glue them together, leaving a 10 millimeter gap here and a 10 millimeter gap on the other side. The reason being is that 10 millimeter gap is going to fit on your rod, which is screwed in there. The other 10 millimeter is where your door is going to fit. You can see it there. Okay, and as I mentioned earlier on, I've put my door opening to the left hand side. You can put it to the right, it doesn't matter really. Here there is the other strip, again glued back to back with a 10 millimeter gap in there and a 10 millimeter gap in there. That is where your door is gonna sit. And then I took very small magnets. Okay, you can get them, very small magnets there, and I fitted 4 magnets on the door. The door handle was also printed with a 3D printer, and as you can see, it closes perfectly. So your door dimension will be 555 millimeters wide by 590 millimeters long. And your back panel will be 650 millimeters wide by 660 millimeters high. Again here, there's the Velcro going. You see that strip is a little bit narrower, so you get the 50 millimeter wide, which then will go over the rod as I've got it here, and that will give it more stability. I only had a piece left, so I didn't make it very neat, but that is what I would do to make it stronger. As you can see, this door, you just close it, and then you can just pull your screen and fit it over. If you want to now create an enclosure, you pull your screen and the Velcro actually goes over your door. Once your print has started, you can just put this over your door, and you've got a totally enclosure machine. Your rods are going to be 650 millimeters long, because you've got a 20 millimeter depth there and a 20 millimeter depth here. And by doing so, then this panel sits snugly and perfectly on top of your machine frame. I've got a wire feeder guide there. So what I did is I opened those holes to fit on the screws, and that stops it from moving at all. So you'll see, and remember the rods are 650 millimeters long, and that gives you the exact height for your machine to fit perfectly on top of your for the perspex, to fit perfectly on top of the machine. Your rods, you will have 4 680 millimeters long, 4 650 millimeters tall, that will go from the top to the bottom, and you'll have 4 585 millimeters wide. That is the width of your from bracket to bracket. I made a hole here on top to let some of the heat escape, and I'm going to start making the filament reel box that will fit on top here. I will then open 2 holes in there, and then the heat will come from there into your filament, and it will dry your filament as you print. So it keeps it away from the humidity and helps your filament to get dry, and in the process you've got better printing. The screen is, like I said earlier on, windscreen shield. It is 800 millimeters high. I'm not sure what is the length, and you're going to need 2 of them. Okay, so this gives it nice flexibility, and you can open and close your machine if you printing PLA or any other filament that needs enclosing. Here on top, as you can see, I have put a couple of pieces of Velcro, and that just gives it a nice finishing, and it prevents the heat from escaping on the side. If you feel it's getting too hot, you can just undo it and lift these two sides, and it gives you an opening for the heat to come out if you wish to. But for me, so far, I feel it gives it a nice finishing, looks nice and neat. And again, there is always room for improvement. So if you feel that there is some changes to be done, well, you are welcome to do so and to share them. So I hope you enjoyed. This video is my first one. I'm not too good at these things, and but yeah, I just wanted to share with you my idea. And like I said, if there are any changes that you wish to make, you're welcome to do so and to share them with other people so that they can make a enclosure that is cheap, efficient, and easy to make. All the best to all of you. I hope you enjoyed it. See you next time. Cheers.